Alright, you made it to the last and final periodic trend. This one is maybe the hardest to understand, so I'm really glad that you've made it this far. Stick with me. This will really make a big impact on your chemistry knowledge. So to begin, right now we're talking about ionization energy. So we talked about ions, we talked about what cations, anions are. Here we go. Now we need to think about the energy it takes to make an ion. How hard is it to make an ion? So to define it, ionization energy is simply the energy required to remove an electron from a neutral. Do you remember what neutral meant? Neutral means charge 0. So the charge is 0. So how much energy does it take to remove an electron from a neutral atom? And let's start with our periodic table, our mini periodic table. So to begin, let's think about the atom with the highest electronegativity. So fluorine loves its electrons. It does not want to give those electrons up. It's really small too, has the smallest radius, and it loves those electrons. So electronegativity increases across the right side. That also means that our ionization energy also increases when we go to the right. So as we go across, we have more electronegativity. Our atom loves its electrons, it holds on to them, and you need lots of energy to kick an electron out. It really wants to keep those electrons. So let's draw the sizes. Remember, so as we go to the right, our atoms get smaller and smaller. It's because we have more and more protons. So our atom bunches up. It's tighter and tighter as we go to the right. So as we go down, however, remember our atom gets larger. Now, electronegativity also decreases because our atoms are floating out in space. So that means as we go down, the amount of ionization energy also goes down. So to put it in words, our atom's getting larger as we go down. The electron is farther away from our nucleus. It's so much easier for it to get lost in the shuffle. So the energy, so ionization energy, decreases as you go down. So the arrows are pointing to where it increases. The arrows point to the increasing trend. So let me show you a picture to help show you this concept. Here is my favorite graph in chemistry. It is the ionization energy of every single atom by atomic number. So if we start at 0, there's no atom at 0. So at 1, it's hydrogen. And you see it spikes at these points right here. That is each period. So as we go across a period, the ionization energy increases up until we get to the last column. So the first one is helium. And then we go all the way to the next noble gas. And then the next and the next. And each time we go across a period, it increases because the ions require more energy to be created. This graph is a little bit hard to understand, but if you can understand how this trend is occurring, you are on your way to really understanding what ionization energy means.